All right. Hello, everybody. Um, okay, so as promised, I am going to be doing some of these videos to help you go through some problems of some of the topics that we've seen that it seems like we are causing a little bit of problems to us. So I'm going to be covering tonight a very short video of one problem on titration. Okay, and I'm going to explain what titration is. Let me share a document with you real quick. All right. So this is a titration worksheet. You are welcome to complete the 4 problems that you see there. I am going to be working on the first one for your information. Okay. A couple of things that we have to remember from titration is that, and I'm sure that you've seen this in the lab. I'm going to go all the way to the right over here, where we have a flask, right? And in this flask, we have an acid, right? And we don't know, usually we don't know the concentration of this acid, like the case from one. And then we have a burette, right? In this burette, we have a known concentration of a base, right? Also, something that you find in this is an indicator, right? And as we have already established, indicator helps indicate when a reaction is complete. Now, what happens here, right? When we have an acid-base reaction and we do a titration, like I said, we don't know the concentration of one, but what we do know is that once we reach the equivalence point, the number of moles of the acid will equal the number of moles of the base. And the stoichiometric, right, ratio, it's going to be the same. So, so we're going to be taking advantage of that to figure out what is it that we're doing. Um, in order to do titration reactions, obviously we do need, right? We're going to need the stoichiometric ratio. So because of that, we need to have a balanced chemical equation. For this problem, it says it takes 83 ml of 0.45 molar NaOH solution to neutralize 235 ml of an HCl solution. What is the concentration of the HCl solution? And that's what we have seen, in the lab. Uh, so a couple of things that we need to know is the chemical equation. We know that NaOH plus HCl gives you NaCl and water, right? And we know that each one of these reactants are in the aqueous, aqueous solutions, and water is liquid. So some of the information that we have and that we have to take advantage of is the fact that we have, right, information for the base, right? That is, we know the concentration and we know the volume. Now, the other thing that we know is that we know the volume of the HCl, right, of the acid. So we need the volume. We don't know what the molarity is, right? We don't know what the concentration is. So how do we solve these problems, right? So remember that our currency in chemistry, it's all about the moles, all about the moles. So we have to take that information that we have and we go to moles, right? How do we do that? Well, remember something, right? Remember that molarity is equals to moles per liter. Sorry, it's moles per liter. So taking advantage of that, then we are going to use the volume of the acid, of the base, and we are going to multiply times the molarity of the base to get the number of moles. Watch, right? Well, first of all, right, we do have ml. We cannot use ml, right? We have liters over here. So we have to convert to liters. Right? Hopefully that you know that by now, right, that we moved the decimal point 3 times. So we're gonna have 0.083 liters of NaOH, right? We're going to multiply times the 0.45 moles per 1 liter of NaOH, right, on both sides. Right? So that we're able to cancel these. And what we get is, let me get this started over here. So we have 0.083 times 0.45, and we get 0.03735 moles of NaOH. Now, guys, mind something, right? At this point, I am not rounding, right? I'm not done with the calculation, so I'm not rounding anything just yet, right? Now we have this part. We have a number of NaOH that, that reacted. That's what we know, right? This much, this many number of moles of NaOH reacted. So we use stoichiometric ratios to see how many moles of HCl reacted. And we go back to the chemical equation, right? And we see that for every 1 mole of NaOH, we have 1 mole of HCl, right? Which means, right, that being 1/1, the number of moles is gonna stay the same of HCl, okay? But we're not done here, right? Because they're not asking us for the number of moles. They're asking us for the concentration of the HCl solution. And we have a set amount of HCl solution, right? So we have moles, we have the liters, right, or milliliters of this HCl solution. We are able to figure out the concentration. So we take the number of moles, right, 0.03735 moles of HCl over the 0.235 liters of HCl. Okay, if you are still wondering, where did I get that to 0.235 liters? That comes from right here, right? That comes from the volume. 235 ml, we convert to liters, we divide by 1,000, so we take the decimal point 3.3 times, right, to the left. So that's where the 0.235 comes. Now, when I do this calculation, what I am going to get is 0.1589, 361, whatever, right? But something to keep in mind is that for our NaOH, we only have 2 significant figures. So I'm going to leave this concentration as 2 significant figures, right? And voila, this is pretty much all you need to do, right, in titration problems. Some of the titration problems might look a little different, right? They might tell you this many reacted, this many, or this much was consumed. Anyway they put it, on, you have to keep in mind that we are looking at the stoichiometric ratios between the amount of base used and the amount of HCl that we started, right? Of the acid that we started. Guys, I am hoping that this helps. You can watch this video, watch it as many times as you need. Please, 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 please make sure that you understand every step that I've taken in order to solve this problem. If you have questions, do not hesitate to contact me. You know that I'm here for you, okay? I will continue with other videos, as I've gotten responses, right, or requests by, some of your classmates. So I'm gonna be working on some of the videos. I'm gonna be posting them, so use them. All right. Okay, guys, that is it for this video. Have a good one.